Section 4.4 is on counting rules. We have two counting rules, permutation and combination. In each counting rules, we have factorial involved. So let's take a look at what we mean by factorial first. For any counting number n factorial, you take n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. So what this really means is that, for example, if you have 5 factorial, meaning that is n is 5, then you do n minus 1, which is 5 minus 1, you have 4, n minus 2, which is 5 minus 2, you have 3. Keep subtracting 1 until you get to all the way to 1. So this is what I mean by n factorial. By definition, 1 factorial is 1, 0 factorial is also 1. All right. We're going to see an example on how to work out factorial. So as what we apply with the definition for 5 factorial, meaning 5 times 4 times 3 times 2 times 1, we can either do the multiplication based on the definition, 5 times 4 times 3 times 2, and you don't have to times it by 1 because it's going to give you the same product, but I just key it in anyway. So this gives us 120. Now, another way to do factorial, you can do 5 factorial completely on your calculator without having to do the multiplication. So if you wanted to do 5 factorial, you key in number 5, you go to math, which is the third key down on the first column, and you use your right arrow, you move it over to PRB. You on the drop down menu here, which we're going to select the factorial function, which is number 4. So you go down to number 4, press enter. So the answer key, of course, is right here. Then what you see here now, we have 5 factorial. Let's enter again. It gives us the result of 120. All right, now since we're on here, let's verify these. 1 factorial, 1 math, PRB. We go down to factorial, and we have 1. 0 math, PRB, going down to factorial here. This also gives us 1. But the scope of our class, we're not going to prove why 1 factorial equal to 1 as well as 0 factorial equal to 1, but we're going to use it to solve our problem. All right, so we have two counting rules, and we have 2 counting rules, and the first one we're going to see here is permutation. What is the permutation? A permutation is an arrangement of n objects in a specific order. So when you think of permutation, you think of order is important. Okay, so permutation meaning that order is important. All right, so what we have here, we have a permutation rule. The arrangement of n objects in a specific order using r objects at a time is called permutation of n objects, taking r objects at a time. And the way we write permutation is like permutation of n choose r. That tells us n is the total and r is how many we're picking out of the total. So meaning that r has to be less than or equal to n. So we cannot pick more than the total, but we can pick it up to the total number of objects. Okay. So permutation of n choose r will be have equal to n factorial on the numerator. The denominator we do n minus r, and then we do the factorial. All right. So let's see how we can evaluate this problem. So 7, we evaluate this expression. 7 factorial, meaning that 7 times 6 times 5 times 4 times 3 times 2 and times 1. This is 5 definitions of factorial. One way we can do it is just apply the definition. 7 times 6 times 5 times 4 times 3 times 2 and times 1. The faster way of doing this problem is by using the factorial function from our calculator. So you see in number 7, you go to math, okay, you move it over, you use your right arrow here, you move it over to PRB is under probability, then you go down to number 4, press enter so that you have the factorial function, press enter again. this would give us the same result. Alright, so then now we know that 7 factorial is 5040. Similarly, for 20 factorial, by definition is 20 times 19 times 18 times 17, all the way down to 1, right? So definitely, no one would want to do the multiplication from 20 all the way down to 1. So it's probably better that we use the factorial function. So we do 20, go to math, go to PLD, go down to the factorial function, and we select the factorial function now. We're going to press enter. Now, what does this result mean? What we have, this result means is that, let me write down the numbers and I'll explain it. So it's 2.43290, 2008 E18. Now, this E18 here, that tells us, so this is the number I get it from, sorry for the lighting. So this is the number that I'm getting from looking at 20 factorial. Now, what is this E18 at the end of our results really mean? It means that the number is being in scientific notation. So this E18 here, it means 10 to the power 18. Well, 10 to the power 18, then we would have to move our decimal point 18 units to the right. The number is positive, you move your decimal point to the right. So here, I'm going to go ahead and move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I move only 9 digits to the right, and I'm running out of digits, but since I need to move 18, then I'm going to add 9 0. So what's this number for 20 factorial? 24329020008, and I'm going to add in 90. All right, this number is way too big to say. My point is that to show you it's possible that you're going to encounter a big number on your calculator, and if it's a big number on your calculator, then you're going to see the result is displayed in scientific notation. But to get to standard notation, you move the decimal point to the left. Okay. All right. So what we're going to do now, we're going to move on to part C for permutation of 5 to 2. Sometimes you see in this one, sometimes you see in this one. It really depends on, where what depends on the textbook, but these two are pretty standard. So now, permutation of 5 to 2, meaning that in this problem, n equals to 5 and r equals to 2. So permutation of 5 to 2, we apply our permutation formula. The numerator, we have 5 factorial because it's n factorial. The denominator, n minus r, meaning that 5 minus 2, then plus the factorial. So 5 factorial, let me just go ahead and write this one out. The denominator, 5 minus 2, which is 3, then we write down 3 factorial. Now, we work out 5 factorial, which we know that is 5 times 4 times 3 times 2 times about 1. 3 factorial in the denominator, 3 times 2 times 1. What we can do, we can simplify the common factors of 3 times 2 times 1. We're left with 5 times 4, which is 20. So, this is one way to solve for permutation by applying the permutation formula. Another way is that you can use permutation function from your calculator to do the computation. So how do we do on our calculator? We key in the number, then the value of the n, then we key in the number for what's n first, then we go select our permutation, then we key in r. So here's what I mean by that. Permutation of 5 choose 2, you key in 5, you go to math, you move it over to PRB, you go down to now. You see earlier we used the factorial functions, which is number 4. We now want to use the permutation function, which is number 2, because we're using permutation here. Then don't go all the way down to 4 at this time, but you want to stop at 2. Press enter. So then it tells us here that we're doing we're doing a permutation of 5 choose, and then you key in your R value, which is 2 in the problem here, press enter. Then we see that we have the same results of 20, just like what we worked out with our definition. Okay. Then what we have next, another counting rule. At this point, we haven't applied any word problems, just to evaluate factorial, evaluate permutation, and now we're going to move on to evaluate combination. So first of all, let's understand what we mean by combination. A selection of distinct objects without regard to order is called a combination. So when you think of combination, you think of order is not important. Order is not important, and we'll go over the detail of what, how can we recognize it's important or not important in a minute. So order is not important, meaning that if you have AB, it's the same as BA because the order doesn't matter here. Versus in permutation that we said order is important. Okay. In permutation, we said that order is important. Then what we have is an example. AB is not the same as BA. So how we can, what does this mean? So for example, Mr. A won the first place, Mr. B won the second place. Here, Mr. B won the first place and Mr. A won the second place. Okay. All right. So we have our combination rule. And here's what we have in our combination rule. The number of combinations of R objects is selected from N objects is denoted by combination of N choose R. So again, combination of N choose R. Sometimes you see in this form, sometimes you see N on the top and R on the bottom. And what we have here for, let me write it first, combination of N letters and choose R. So just these are the two standard forms that we write combination. All right, so here's what we have in our formula. We have the numerator is N factorial. That's very similar with what we've seen from permutation on the previous one. The denominator, we have N minus R factorial. That's pretty much the same as what we have from the permutation formula. Then what we have here, we times it with R factorial. So what do I mean by that? Let's apply to our problem here. Evaluate the expression combination of 5 choose 2, meaning that N equal to 5, R equal to 2. Combination of 5 choose 2, meaning that we apply our formula. We have 5 factorial. The denominator, 5 minus 2, take the factorial. Then what you're going to do, you times it with R factorial. This is how it's written in our textbook, but we know that it really means times it with R factorial, which is 2 factorial. Okay, then let's work it out. 5 factorial, the denominator 5 minus 2, which is 3 factorial, and we're taking 3 factorial, we're timing it with 2 factorial. Okay, then what we have here, we work out 5 times 4 times 3 times 2 times 1. The denominator 3 factorial, 3 times 2 times 1. And notice that I line up the factors on purpose so that it's easier for the simplifying part here. Then now, this here, the 2 factorial, you just continue to multiply by 2 times 1 because that's the meaning of 2 factorial. Then now, we simplify the common factors. We left with the numerator of 5 times 4, which is 20. We left with the denominator of 2 times 1, which is 2. So 20 divided by 2, our result, we ended up with 10. Now, let's verify this using the combination function from our calculator. So what you do is, you key in the number 5, you have math, okay? You move it over to CRV, and go down to combination, which is number 3 this time. So we're not doing factorial, we're not doing permutation, but we're now doing combination. Okay, so combination of 5 choose 2. You key in your second value of R, and we verify that it's identical to what we worked out with the definition. Okay, let's try another one here. For part B, I have combination of 10 to 4. What is this telling us? N equal to 10, R equal to 4. Combination of 10 to 4 is 10 factorial, 10 minus 4 factorial, and we're going to times it with 4 factorial, okay? So 10 factorial, I'll just write it here. 10 minus 4, which we have 6 factorial. Then we're timesing it with 4 factorial. Okay, so again, from here, we can work out what we have for 10 factorial. By definition, 10 factorial is 10 times 9 times 8, 7, 6, 5, 4, 3, 2, and 1. Okay. Then denominator 6 factorial, meaning that 6 times 5 times 4 times 3 times 2 times 1. Here, this 4 factorial, we're going to bring this 4 factorial over, which gives us 4 times 3 times 2 times 1. All right, then now what we can do, we can simplify the common factors from 6 down all the way down to 1. So what we left with the numerator, 10 times 9 times 8 times 7. 10 times 9 times 8 times 7, which we have 5,040. So I'm going to go ahead and, sorry, I'm kind of, the space here is a little bit limited, so I'm going to go ahead and write 5,040 here. Sorry about the spacing. The denominator, we have 4 times 3 times 2 times 1, which we have the denominator of 24. We now take 5,040. We're going to divide it by 24. This gives us 210. All right. Now, if we use the same, numbers for N and R to do the combination of 10 to 4 using the combination function from our calculator, will we get to 10? Let's find out. So we do 10, we do now, move it over to PRV. We go down to make sure you select the function that you want to use for the problem, okay? So this one, we're doing combination. So we select number 3, 10 choose 10 choose 4, because our R value is 4 in the problem, okay? That's it, that's 210. All right, so now that we've practiced on how to do factorial, how to do permutation and combination, all by hands, all by using our calculator. So we're going to look for keywords that help us to determine when to use the combination formula versus when to use the permutation formula. This is very, very important. You're going to study these keywords will help you to apply the correct formula. So like we said that combination, that means order is not important. So AB is the same as BA. Okay, so we'll write example. AB is the same as BA. Versus in permutation, order is important, so that AB is not the same as BA. How many different ways? When it's just asking you how many different ways to select 3 people from a group of 5 people, that's just a combination. But when different is written like in italic, that really means, I know mathematicians sometimes we use like repeated words. So different is like quote unquote, or it's like in italic here, then it will really mean different. So that indicate that permutation versus when it is different is as normal writing. So look for your assignments on ALEKS, on the quiz, on exam, when you see the word different, making sure that the writing is the same with the rest of the sentence, then you use combination. But you see that is written in italic, meaning that you wanted to use permutation. When it tells you disregarding the order of selection, meaning that order is not important, that's combination. When it tells you in a certain order, meaning that order is important. Okay, let me let me show you some word problems. Okay, so what we have here, how many four different color stripes can be made on a scorecard if each code consists of the colors green, red, blue, and white? So meaning that n equal to 4, and we choose all 4, okay? There are 4 colors possible, and we choose all 4 to form a stripe. All colors are used only once. So for example, here, I'm going to have red, white, blue, and green, right? So this one stripe is in this order. Another stripe color, that what if I change the order to white, to green, to red, and to blue. Obviously, the first stripe is not the same as the second stripe because we changed the order of the color, right? So here it's telling us order is important. Because of the different order of the colors, we get different stripes. So order is important. That tells us permutation. Permutation of 4, choose 4, okay? I already worked out in your guided notes, so I'm going to share my calculator to show you how to do the computation. Continue practice on the calculator here. So key number 4, math, move it over to PRB, go down to, sorry about that. 4, go down to math, move it over to PRB here, and we're going to select permutation. Permutation of 4, choose 4, and this will give us 24. Okay. Threatened species of reptiles. There are 22 threatened species of reptiles in the United States. How many ways can you choose 4 to write about? And notice what it's telling us here, order is not important. That's the hint in the problem. As soon as you see order is not important, you're going to apply the combination formula right away, okay? All right. So there are 22 threatened species. That means n equal to 22. And in the United States, in how many ways can you choose 4 to write about? Meaning that r equals to 4. Combination of 22, choose 4. Okay. Then how are we going to go about it? We do 22, math, move it over to PRB, go down to combination, 22, choose 4. And here it is, 7,315. Now, it's really up to you when you do the work. Should you use the calculator function to do whether factorial, combination, permutation, or should you use the formula? Whichever way that you feel most comfortable with. Since we already know how to do a multiplication on the calculator, that's why I'm not showing by the definition. ID card. How many different ID cards can be made if there's 6 digits on an ID card and no digits can be used more than once? Okay, there are 6 digits on a card. That means this number 6 here is R. We're picking 6 digits, okay? This is not the value of n. So now, in previous problem, we see that there are 4 colors, we choose 4. So n equal to 4, R equal to 4. Here there are 22 plant species, we choose 4 to write about. So n equal to 22, r equal to 4. Here we're picking 6 digits on an ID card. So for example, here's an ID card. Sorry, my drawing is bad. A smiley, that's why I intended to draw. Okay, so let's just say this is my ID card number 147892. Okay, so where am I picking these digits from? The digits we picked from are base 10 number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The problem does not explicitly tell us we're picking from 0 to 9. So meaning that n equal to 10 in this problem. It does not explicitly tell us, but we are in base 10, meaning that the digits here are 0 to 9, which we have n equal to 10. Now, I'm gonna give myself another example to ask myself whether we are doing it by permutation or combination formula, right? So here I provide myself with an example that I change the order of the color. Do I have a different stripe? The answer is yes. Now the same goes. I'm gonna change the order of the digits. I'm going to still use these digits here. But what if I have 7, I have 2, 9, 8, 1, 4? I'm using the same digits as what I have in the first ID. Do I have a different ID number here? The answer is yes. So meaning that these two ID cards, these are two ID numbers here, they're completely different. That tells us, even though it does not tell us whether order is important or not important, we're able to draw a conclusion. Order is important. Because order is important, then we're going to use the permutation formula to solve. So it's permutation of 10 to 6. So this problem is a little bit tricky because we have to identify what's the n value. And it's possible that you're going to encounter a problem like this when you do your homework assignment on ALEKS, or it could be a quiz or an exam problem, okay? Permutation of 10 to 6. Order is important because of different order, we get different ID cards. So 10 now PRD and go down to permutation, which is number 2 here, and we're going to choose 6. This gives us 151,200. And in fact, this is how we generate our social security number, the same digit, but in a different order, we get a different social security card. Or how we generate our license plate. We use combination of 10 digits and 24 letters to generate our card's license plate number. And even with the same digits, with the same letters, but we're rotating, the two different positions, and that would give us a different license plate. That's why order is important in this problem. Now, this next one, how many ways are there to select 3 bracelets from a box of 10 bracelets? So this is very straightforward. From a box of 10 bracelets, that tells us 10 equal to 10, and we choose 3, right? Now, another clue in the problem is regarding the order of selection. If we go back to our keyword page, when do we use combination versus when we use permutation? Combination is when order is not important, or disregarding the order of selection. So this problem here, we know that it is a combination problem. Okay, so what we have here is combination of, what do we have? 10 to 6, and we just work it out, okay? So 10 math, move it over PRD, go down to combination, here number 3, 120. All right, now number 5, how many different ways can a CD health department inspector visit 4 restaurants in a CD with 12 restaurants? So meaning that n equals to 12. Now keep in mind, n is always greater than or equals to r because n is the total and r is how many we're taking out of the total, okay? We cannot pick out more than what we have, right? So therefore, n has to be greater than r. Notice in this problem, how many different, and the word different is written in italic here, right? Then we go back to our summary page from earlier. If we just see how many different ways, that's a combination problem. But different is written in italic, that represents for different size, for order matter, then it's a permutation problem. With that being said, then that tells us in this column here, the order that they inspected, the order that the health department inspector choose to visit these 4 restaurant matters. So meaning that permutation of 12 to 4. Okay, and what we have here, permutation of 12 choose 4. I know that you have the answer already, but I like to continue to work on the calculator so you can see that this time we're using the permutation function. And 12 choose 4, 108, what is it? 11,880. All right, so that hopefully that gives you a variety of examples on permutation and combination. I do have extra problems on the back, which I can go over with you here. Continue to go over with the problems with you. Manufacturing test. An inspector must select 5 tests to perform in a certain order. Okay, so we come across to in a certain order, meaning that order is important. Okay, on a manufactured part. He has the choice of 12 tests, meaning that a total n equals to 12. He's choosing 5. And how many ways can he perform 5 different tasks? Because of the keyword in a certain order, so that means permutation of 12 is 5. Okay. Now, what we have here, this number 7 on cell phone problem. A particular cell phone company offers 6 models. So there are 6 model phones, each in 4 different colors, okay? And available in 2 different calling plans, all right? How many combinations are possible? So we know the combination. There are 6 models, so 6 models choose 1. 6 models, we're going to choose 1. That tells us for the models, we're going to have combination of 6 choose 1. How many colors? There are 4 colors, so 4 colors, we choose 1, okay? And the 2 calling plans, there are 2 plans, we choose 1, so combination of 2 choose 1. All right, so now, it's not too obvious in this problem that we choose 1, but think about it. There are 6 models, right? Then there are 6 models, then you choose 1. There are 4 colors, you choose 1, and there are 2 plants, you choose 1. That's why we have the number 1 here, okay? Then now for each one, you just do the computation separately. Combination of 6 choose 1. So 6 math PRV, you go down to combination, okay? Which is number 3, choose 1. You ended up with 6. So combination of 6 choose 1, there are 6 ways to choose it. There are 4 colors, so the combination of 4 choose 1. Combination of 2 choose 1, you will have 2. And this you multiply it out. 24 times 6 times 4 is 24. 24 times 2, which we would get 40. Very basic math here. All right, so what we have here, how many ways can you choose? Can you make one table? Excuse me. How many ways can you make one table 5 from 20 potential bridge player? Then you're just choosing 20. You're choosing 5 out of the group of 20. So that's pretty straightforward. That n equals to 20 and r equals to 5. The order doesn't matter. You just choose 5 out of the group of 20. And if you work it out, what we have here, we have 20 math PRB, and we go down to combination, 20 choose 5, we have 15,504. How many different tables of 5 players? How many different tables if 5 players insist on playing together? Okay, now we really need to be careful on this one. What we have here, if 5 players insist on playing together, we have a total of 20 players, but we have 5 players insist on playing together. This is one group of 5 we need to take away. So that means we only have 15 players left. Okay. Now we're going to do combination of 15 players left, and we're choosing 5. Okay. So 15 now, PRB combination, 15 choose 5. This gives us 3,003. Now, but that's not the final answer yet because we have a total of 20 players. And we're taking out 5 players because these 5 players, they insist on playing together, meaning that we have a special group, okay? These 5 are not rotating. So one group of 5, right? So here we have 3,003 and we need to add this one group of 5, meaning that we should have a total of 3,004, okay? Does that make sense? All right, this very similar with number 9, so I'll leave that for you. Okay, and what we have here is example 3. How many ways can 4 baseball players and 3 basketball players be selected from 12 baseball and 9 basketball? All right, so we have 2 categories. So baseball, how many ways can 4 baseball and choose from 12? So that means N equal to 12, R equal to 4. Basketball. There are 3 basketball players. Choose from a group of 9. So N equal to 9, R equal to 3. Okay, we're just picking 4 out of the group of 12. So that's combination of 12 choose 4. We're just picking 3 out of the group of 9. So combination of 9 choose 3. We're going to work out each one here. 12 math, PRB, go down to combination. 12 choose 4. 495. And here we have 9 choose 3. 9 math, PRB, we choose 3. We have 84. Then now, to figure out the total, okay? So let's just say you have M ways of doing things, and in one group, you have N ways of doing things in another group. What's the total? The total, you're going to take M times N. So likewise here, to find out what's the total, you have 495 ways for basketball. You have 84 ways for, you have 490 ways for baseball and 84 ways for basketball. You're going to multiply them together. So take 495, timesing it with 84, which you get 41,580. This would be the total that you're looking for in the problem. So what's the takeaway for this example? Whenever you have 2 categories, you find out the total of the first category, you find out the total of the second category, then you multiply them together, okay? And we have one last problem to help you to understand the difference between combination and permutation. Given the letters A, B, C, and D, list the permutations and combinations for selecting 2 letters. Okay, so with permutations, what do we have? We cannot have A and A, but we can have AB, AC, AD. We have BA, we cannot have B with B, but we have BC, BD. We have CA, CB, we cannot have CC, it doesn't make sense, but we can have CD. We can have DA, DB, DC, but we cannot have DD. All right, so permutation, these are the permutations of 2 letters. How many letters here? 1, 2, 3, 4, meaning that N equal to 4. And we're selecting 2, meaning that R equal to 2. And if you do permutation of 4 choose 2, okay, let's see. 4 math, PRB, you go down to permutation of 4 choose 2. This will give you 12. And let's find out how many did we list here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know we got it. Okay. Then now for combinations, what we have is AB, that's the same as BA. So AB is the same as BA. So meaning that these 2 are done, okay? are counted as one combination. Next, we have AC, that's the same as CA. So these two are the same, okay? AD is the same as BA. So you kind of get the idea of what we have here. So AD is the same as BA. So basically, we're taking half, right? So BC is the same as CB. BB is the same as BD. CD is the same as BC. So 1, 2, 3, 4, 5, 6. All right. Let's see if this is true when we do our computation. Combination of 4 choose 2 because we have 4 letters and we choose 2 here. What happens when we apply our formula for combination of 4 choose 2? Will we end up with 6? Let's find out. We sure do. Okay. So that means that these 6 combinations, we list them out here, are all the combinations we have for choosing 2 letters from a group of 4. These 12 permutations that we list them out here are all the permutations we have for 4 letters choosing 2. And I hope that with this last example, that helps you to understand what we mean by combination versus permutation and how to do the computation. That concludes our lesson for section 4.4. And in fact, this would be our last section of chapter 4 as well. So thank you so much for watching. If you have any questions, please feel free to reach out to me from Alex, or you can do Canvas message. So I'm only one message away. So thanks for watching. Bye-bye.